I'm currently speaking from Pakistan, Karachi. So I'm super excited to be here. This is my first time at Android Summit, and I'm going to share my experience about how I actually built Chrome's Dino game in Jetpack Compose. So I'm a Google developer expert in Android, and I have been working for Android for like 6, 7 years. And I also do some open source contributions, and I have also written two worldwide published books plus a lot of articles. So you can check my work at my website, wajahat.com, and also please follow me on Twitter. I keep sharing the good stuff there. So you must have seen already the game. Everyone has played it when there is no internet on to a PC. So let me show you the actual game. So yeah, this is running from my mobile. So Jetpack Compose, according to developer Android website, is a modern UI toolkit which simplifies and accelerates UI development. So my question is that this is about UI toolkit and this is about UI development. Then why even do games in it? Like this is not supposed to be for game. This is supposed to be for UI. That's what their original definition is. So I wanted to see it, and I wanted to see that what kind of capabilities lied in Jetpack Compose, and what we can actually accomplish with it. So I went ahead. There is very awesome work by Alex Lockwood already on this. Like there are a lot of you know cool animations he have created. Recently, he have also created 2048 game in Compose. So it's super awesome and I love it. These are some of his animations and you can see that how awesome they are. So I wanted to delve into game development because I have been initially I was in game development and later I shifted to app development and I wanted to try it and Canvas is very much friendly in Compose than the usual Android View Canvas. So its APIs are very easier and understandable. Of course, there are some limitations for now, but I hope that they will be fixed once Jetpack Compose gets more stable and more release. So also this is perfect for animations, even UI animation. So I will start with game development 101 course. So usually games are very different than software development because software is mostly about event driven structure like if user does not press any button or user does not respond to any event or action, then software will be static there and it will not do anything no matter how many days or years have passed. So games are different. There is a very limited time, like 200 milliseconds or 100 milliseconds. Game will wait that time for you to actually see that whether you have pressed anything or button, and if there is no input, it will move ahead and continue. So if you do not do anything, someone will come and your game will be game over. So yeah, this concept is called game loop. So usually a simple game structure as a startup, intro, movie, then main menu and setting, loading, main game. So we have intro, then gameplay, pause, and game over. So our Dino game does not have this kind of stuff. It's a simple game. So it starts from main game. There is no intro. It's directly with gameplay, and there is no pause option. So it's either game over or exit. So then we don't have any levels or credits. So uh, it's a simple game, and but it was a little tough and challenging to make it in work in Compose. So let's see that what is the game loop. So as I said that game will wait for a minute, and then it will focus, move on and do the thing. So these are usual simple structure that initially we have loaded resources, icons, models, and anything, and then game loop start. This is the game loop. So uh, first, it will process input 100, 200 milliseconds. Okay, did user tap on the screen? Did user press A key or not? Okay, then the game's data will be updated accordingly. Dino needs to jump or something like that, and then it will render the whole new state, that what state has updated, and then we'll check that if loop needs to be shut down or continue, like whether Dino has collided with any cactus or not, and similarly. So, so this is a game loop. Now we will focus on a little about Canvas, Jetpack Compose Canvas. So if you see into the definition of Canvas in the Jetpack Compose code, you can see it on cs.android.com. It's a very awesome website. It's helped you a lot with figuring out that what is supposed to be done in Jetpack Compose. So yeah, it's a simple spacer, nothing more. Like it's a simple spacer, and you can draw on it. That's it. And you can put a modifier that what is the width and height of that, and similarly, and then you can define that what it needs to be drawn. So it's a draw scope. I'll move on to that next. So currently, Compose Canvas has these methods. You can draw rectangles, oval lines, and images, and rounded rectangles, circles, arcs, paths. So you can. This is like your canvas for painting, and you need to show your creativity and see that what you can come up with here. If you have any your custom shapes like polygons and something like that, which does not lie in this scenario, or you need to mix multiple shapes with each other, then you can define your own functions. But remember that you need to actually uh, make a extension function of dry scope, because otherwise you won't be able to call it in your dry scope. So this is a good approach, and I have seen it do wonders. Like this will do a lot of job easier for us. We'll see that. So now putting into the action that I have defined a canvas. I have said that this is maximum size, so this will fill whole screen width and height. Then I said that okay, draw a 300 radius rectangle, so it's a red circle. Then I said okay, draw another one on center with 200, so it's a green one. And then I said okay, draw a blue one. So this is your custom view. Imagine that if you need to implement this view in traditional Android development, then you have to extend the class from Android view, then you have to focus on measure method, then you have to focus on attributes, and you have to figure out that what is draw supposed to be done. And then if you create some more animations, like I did a flip view animation, I'll be explaining tomorrow on dry content. So so this is going to be a lot more effort, but in Canvas, and especially in Compose, it gets a lot of simpler. Especially if you mix Compose and Canvas, then you got a whole lot of power, which I don't think that any existing Android API is providing yet at this moment. So now let's see that how we can make a Dino game. Okay. So starting from basics. So first we need to actually build a game scene. So this is our screen. This is our X uh, from the left to right, and this is Y from top to bottom. Dimensions are little, reverse in screen. So you will get it. So we have device with 10 pixels. I needed that because a lot of calculation depend on that, and this is in my case Earth-wise. So this is where our Earth will be placed. So This is the code for the device width. It's a simple display matrix, nothing fancy. This is usual way for getting the width or height of the device in pixels. And I have fixed it like 500 pixels. So this will be from top. We can make it like 30% of the screen height or 70% of the screen height. Adjust it accordingly, but 500 work good for me. So now we have to make art. So it's not some fancy view. I created a Kotlin extension method for each kind of shape I wanted to do it, and I called them in canvas uh, together, and boom, we got a game. So this is a method for the art. It's simple one. So first is ground line. This is from starting from 0 to and y is y position, and ending is devices. So this will be the first line, bold line in black. A simple line would do a job, but we will not be able to distinguish that whether this is scrolling or not. So I wanted to make some inconsistency to make a experience like screen is actually scrolling. So I created two more text lines with different parameters to make a random pattern. So yeah, this is similar. The only difference is that we have stroke with path effect. So we don't have any path effect, so that's why it's a bold line. In this line we have a path effect. That is a dash path effect. So these are dashes, and these get the value like two parameters. One is that how much dash width will be, and other one will be how much distance will be to dash. So I have created two dash effect paths, one with 2040 and other with 50, 1550. So below line is small stroke and more width. So now we will come into the animations later, but for now we are focusing on actually drawing our custom scene and see that how our ideal positions of everything is supposed to be. So next is vector icon for all of these. So I picked these all icons from flaticon.com, and I wanted to draw these. So I figured out that initially when I actually draw all these icons in canvas using the draw path method, uh, they were like cloud is so big and dinosaur is so small and cactus is between the sizes of both. So it became a little hard for me to manage. So initially I approached the method of manually scaling them down, like uh, dinosaur is with lot of pixels, so I scaled it in Jetpack Compose canvas. But later it got complicated, and I had to find a good way. So that was that I actually resized all these images 200 by 200, and later applied my own scale, which was uniform scale. So I'll show you that bit in a code. So now we have this 200 by 200 code, and this is Android drawable. But we in Canvas there is no method to draw any vector drawable or Android drawable. Ideally, there are two things. Number one is width and height. Number two is viewport width and height. So if your vector drawable size is width and height 200 dp, then it doesn't matter that how much pixels are being allocated for the drawing of the path actually. But this is only supported in vector drawables, and for the UI, vector drawables are very good, awesome, scalable, and cool. But in Canvas, we didn't have that luxury, so that's why I had to manually, scale the vector drawable resources. But later, I was unable to draw these vector drawables in actually, on Canvas. So I had to find a way, and it was that I had to copy this whole path data and put them in, you know, code. So This is an example. So we have path data str. This is actual path, the whole path from zero to whatever it is. So I had to copy this all manually. For now, I believe that at some point Canvas will be able to support the uh, Android vector drawbles. Uh, then I pass this whole path from string to compose part. So we have an API from compose for that. And then I created the path nodes. So now I have a path which I can actually draw on Jetpack Compose canvas. So yeah, I created a method for this cloud path. So this will give me that cloud path. And as I said that initially I had all icons resized to 200 by 200, and then I applied a uniform scale on that. So that's why I used these scale metrics. So once that done, I got my path. So remember that there is a difference between Android part and Compose part. So, but also there are extension methods to convert between these. So initially, path parser will give you an Android part, then you need to convert that into Compose part, and that will be drawn on Jetpack Compose canvas. So once that's done, then I define the method for dry scope. That was for the cloud. So it draws a path, and it requires a cloud.path, and I created this method. So rest is like you have got a cloud in your game. So I applied same approach for all in the cactus and in T-Rex. So this is exactly same. And the only one thing I noticed that T-Rex has a lot of different parts like Dino. So yeah. So you can see that we have a lot of parts for the T-Rex Dino. So I had to manually copy these one by one and differentiating between the spaces. So it was a very long part. So for now, I don't know any other method to do this more optimally, but for now this works. So now let's move. So we got all things together. Now let's just put them on canvas and see what happens. So I defined a composable Dino game scene, and I put a canvas with whatever size is left, which is obviously full screen. And then we have earth view, cloud view, dinosaur view, and the cactus. What happened? No, we didn't get any game. We got it like this, all crammed into one place. So what I needed to do is like, uh, transform them. But first, we will focus on game loop and see the animations actually. So when I started this side project, I had some assumption from my old, game development experience. So I assume that Compose is very reactive to the state changes, like state of remember and all that. So this will solve a lot of issues. Like we don't need any complexity. Like all we have to do is update the game data, and Compose will react to it and render it automatically. So that was my first assumption. So I was like, why we even need a game loop? We just need to define some composable methods which will react to state changes, and Compose will do it like this. But obviously, I was wrong. It was not like that. So when I did that, there was no update. Like game is still nothing is moving. Cloud is supposed to be moving. Cactus is supposed to be moving, but nothing was happening. Compose was not reacting to the state changes. Although when I debugged it, I found that variables are changing, values are updating, but state was not updating. And so I started playing with it. So my first attempt was, as I said, that I made a data class for cloud model, X position, Y position, path, obviously cloud path, and then other was the cloud state. So this is contains the list of all the clouds, maximum cloud free at time, and with a speed. Like this is a factor that how much X will change based on this, and then we have remember. Okay, the good old remember, it works awesome in UI, but when I did dummy game loop, it did not work. I was increasing X position, but it did not work. It didn't happen. So this was felt. Now I had attempt number two. This I got it. You might wonder that Adam, there was a person on Twitter. He created, Doom's fire effect and Jetpack Compose. So it was really awesome. So I looked into his code and found out that he has used choreographer frame callback. So uh, you can see that we have a game loop callback, choreographer.frame callback, and this updates on each frame. So I was updating the value of cloud state, like move forward, so it will decrease the X position and on each iteration. And I was said, okay, now state is being updated. Now compose should react to it, and canvas should react to it, but still value is updating, but there is no animation on cloud about Jetpack Compose. So that was that. So no cloud animation again. So then I started with another one, mostly from the George Costello and Alex. They were creating these cool animation. So I wanted to see that how they have managed to pull it together. So I found this method, animation time release. So this uses the coroutines inside the compose scope. So we have this state variable, millis state. This is supposed to be updating on every iteration, on every frame. And then this is a loop, which is infinitely true. So with every like iteration, uh, millis variable will be updated. And then we return that millis variable, and we use it for our case like this. So time is that equal to animation time millis. So now we have millis here. Okay. Now this variable is very critical. I'm not using it anywhere inside the whole game, and there is no functionality related to this variable. Of course, you can do it if you want to do it, but this variable, whatever composable I will put this in, that will be updated continuously. So, so this is the key. Like I am calling this from Dino game scene. So Dino game scene composable will be recomposed on every frame. So this is exactly what I needed. And now every frame is being recomposed on each call. So that's why clouds are working, and this worked. Like this was very good, and this is awesome. I used it until Jetpack Compose Alpha 4 came, and then I updated it like a few days ago. So now this is a new variable, and this comes with animated float. So idea is that we have animated float with initial value 0, and then we set the target to 1f, and define the NMS spec with repeatable infinite. This will run infinitely, and then we have like a duration every 1 second. So this is similar thing, like exactly similar, just in written in more composed way. So of course you can use the previous method as well. So uh, nothing fancy, same. This variable is not being used anywhere. This is just here for purpose of recomposition of this composable. So I have the Dino game scene composable, which manages the whole game scene and stats and everything. So now game loop is updating and we have render scene. So this is update data, this is render data, and rest is done by compose. So that got us again everything, but it did not work with as expected. Like composable is being redrawn, state is being updated, but we don't have things moving. All are because as templates. So we needed to do this. On each canvas redrawn frame, we have to actually apply transform. So we have three transform, translate, rotate, and scale. So if we have to move the cloud from one place to another place, we can use translate, and then there I use the cloud's positions x and y, and x is continuously getting decreased based on the speed. So this is how clouds are moving, and on each frame there is new cloud drawn, and that's it. So this got me foundations of the game, and the rest was a lot more easier. It was more about mathematics, that how much mathematics you can handle and how much mathematics you can draw on the screen. So now let's get back. So next is earth. So idea is that there are two blocks of earth like this, and one block is of the device width, like from here to here. So they are getting moved, and then another one comes and move, and then another one comes. So uh, user will be able to see only one block, but there were two blocks, and they were following each other again and again and again and again. So I had to create that, and so like this you won't be able to figure it out that where's the difference, because there are two lines, and once one line is completed from here, then it follows that from there. So this is a simple method I created for artist set. So end position, and then x position plus size. So yeah, uh, there is the speed factor, that how much speed we want to do it, and once first block is read at the end of the screen, then I have figured it out with minus earth offset, because my earth offset was like 0 for this one. So block position will be again end position. So it will be this. So it's a simple mathematics. So now I use the same strategy almost for the other generation. I needed a spawned algorithm for cactus and clouds. I wanted to make sure that there is enough gap between both cactuses, so that Dino can jump. Otherwise, game will be impossible, and it will be frustrating to play. So I needed to consider that. Otherwise, the rest is same. Like we have position speed here, that each cloud x is getting decreased, and then if any cloud is out of the screen, then it will be again randomly generated behind the screen, and it will follow from there back into the screen. So this was a continuous loop, and it was working good. Cactus was good and everything was good. Now I needed to jump. So yeah, so I needed to make jumps for the dinosaur game. So idea is that we have this whole canvas where earth view, cloud view, dino view, cactus view are done, and I put that in whole column and made it clickable. Indication null defines that there is no ripple effect. Otherwise, there was built-in ripple, and it was very annoying, honestly, while playing. Like every time you jump, there is a ripple move. So yeah, I removed that, and I put the logic about that whether game is not over, then dinosaur can jump. Because if game is over, then what's the point of jumping, right? So Now let's see that how that jump is actually built in. So there are two ways. Number one, that we can like define offset of the y position, like dinosaur will decrease its position by 50 pixels, and once it's there at 50, then it will come back to the zero. So this was good, but this will not make a realistic effect. So it will not feel like a good jump. It will feel like a simulated effect. So I added the gravity for this purpose. Like when dinosaur can only jump when it's on Earth, and then I set these variables jumping true, and there is a velocity which is minus 40, so it will. This is like a push with push of minus 40. So it will make Dino jump to the minus 40 position with a push, and there is a gravity of 3, so it will keep adding that 3 into our velocity, and soon our dinosaur will be back onto the ground. So it's simple, and once dinosaur is on Earth, then gravity is 0, velocity is 0, and jumping is false. So that's how it was made a jump. Also, there was one interesting approach about keyframes in Jetpack Compose. Like I wanted to make a running Dino. So we have usually four keyframes, but I played around with two. So idea is that instead of one part, there were two parts as I defined it. So first there was keyframe current keyframe and two parts of separate dinosaurs, and then I had this getter that whether we define that when to show first part and when to show other part. So I was keep altering 0 1 0 1 0 1 0 1, and this function was getting called alongside with other move forward methods like keyframe plus plus. So if keyframe is 1, then make it 0. So okay, so this gave the canvas that particular part. So at one frame it was one step, then at other frame it was other step. You can use the same strategy for applying on multiple keyframes and jumping, eating, uh, scrolling, and whatever condition state you want to create. So now there was Boolean detection. Now this was a problem. Like I wanted to see that what is actually happening on like Boolean. Like I had to make sure that what is the bounding box. So I created my own dry scope method, which needed a color and rectangle, and I created two colors. One was outer and other was inner. This is a common game development practice that uh, it will look like this, but it will only collide when inner circles are, overlap each other. So this is to make games a little playable and giving the user a little benefit of doubt. So I created this method and called it every composable, like cactus view and dinosaur view, and it did help me with debugging a lot. Like I had I was able to see that where dinosaur is, where cactus is, and each bounding box had two lines, deflating lines and outer lines. So it was a very good approach. I really enjoyed it. So now, collide detection. Yeah. So now we had to actually write Boolean detection. I wrote it inside the game loop. So this is where state is being updated, like increasing scores, clouds are moving, earth is moving, cactus is moving, dinosaur is moving. Obviously dinosaur is not moving, but dinosaur is jumping around. So that logic was in this side, including the keyframe change. So after that, I was going through the whole cactus list and checking that whether dinosaur is colliding. So for each, I actually used deflate method. So this was to make sure that only inner circles collide, not the outer circle. And once that's done, then game it over and loop pauses and we show the real game score. And scores are easy. I added a composable hypertext view, and this was simple. Like we have a spacer, and we have some row with text high and that, and score was getting updated into the game loop on each frame. So that was being shown here, and then in the game loop, in the game over function, I put this logic that if the high current score is more than high score, then update the high score and something like that. So there is no rocket science. And once that's done, then we have game over. So I put this again another game over text view after the column, and that I put the icon and show the text, and the rest is you will figure it out. So summary: this was canvas. We saw that how canvas works, and what can we do with canvas, and we also saw that how to make loops, game loops in Jetpack Compose. We tried 4 different approaches, 2 of them worked, and we also saw that how to draw vector paths on Jetpack Compose canvas, and we saw that how state is managed for games or animations or that sort of stuff, and we also saw that how bounding box works. So that's Army exactly on time, I guess. So um, please go ahead and ask any question. Code is available on this link, Dino Compose. I keep updating it. I recently added like dark mode inside it, and please follow me on Twitter and check my website. So yeah, thank you.
Thank you, Bahajit. That was a very interesting talk. Um, if you guys have any questions for Wajahat, you can ask him now, or just type it in the chat.
So are the questions in chat? I can't see it.
Yeah, currently I don't see any questions in the chat.
Okay.
Right. Thank you again. It was a good talk, and I'll stop recording now. Oh wait, we have one question. Would you make
Uh,
another gaming app?
Yeah, I can see the questions now. Yeah, hello Brady. Thank you for listening. So yeah, I'm actually thinking of one. I have a couple of ideas. Recently, Alex Lockwood has created 2048 game in Compose, and I was looking at its code, and but mostly for now I'm focused on UI animations. Even tomorrow I have a talk at DroidCon with showing about how we can actually create different kind of animations in Jetpack Compose. So yeah, I think that Compose is very good for games and animations.
Cool. Thank you for that.
Thanks. No problem.
Do you guys have any more questions? Right. Thanks again. Wait, we have one more question. Do you think it would be helpful to make the library available for this?
So like for the game.
Or using
Yeah,
it?
I think it would be a good idea, but I'm not sure that in what condition people will use it. Like as Google Chrome did with when internet is down, so you will use similar effects in the applications. Like internet is down, you get to see this Jetpack Compose game. So if your whole application is in Compose, then it would be very easy to integrate that. Also, because it's a big code like multiple files and uh, like a couple of hundred lines of code. So yeah, I think it would be a good idea. How does Jetpack Compose compare with Flutter? So I have very briefly worked with Flutter, and I got this inspiration of creating game in Jetpack Compose from Flutter because I was seeing that a lot of people are making this generative art like based on the calculations like mathematics, and the stars are being drawn and circles are overlapping each other. So I wanted to see that whether I could do this with Compose or not. So yeah, I think that Flutter is way more better. Compose is still in early stages. So yeah. Also, there is a Slack channel for this talk. I think T1 S1 T1. So if you have any more questions or want to talk more about this in details, I'm there available. So you can ping me.
Okay. Thank you again. We'll stop recording now, and if you have any questions, please reach out to him. And we have another session starting at 2 p.m. Thank you.
Okay. Thank you both for attending. Thank you, Android Summit. Uh, thank you. Bye bye.
Bye bye.